Brianna.
No, I'm not.
Oh, there you are. I figured it was 9 o'clock, so. Right, okay, so who are we missing then? Have we got everybody now? Okay. Anyways, next what we're going to have a look at is geometric progression. Geometric progression. Okay. There we go. Geometric progression, or just GP. Oh, can you adjust the focus a little bit? It's a bit blurry. You know, the very front. Forward, more. The glass, the lens. No, forward. Yeah, there we go. Yeah. Okay, great. All right, who knows? Well, I'm sure a lot of people know this. Geometric. What? Geometric? What's last time was arithmetic, where we have to add each time, and what's special about geometric? You have to multiply. Yeah. So, for example, let's say something like 2, 4, 8, 16, 32, etc. What are we multiplying by each time here? 2. So this is an example of a geometric sequence. So just like with arithmetic, we have some notation. What we multiply each time by is called R. Yeah. So here we're multiplying by 2. So that is called the OR, the common ratio. And no surprises again for what the first term is. Just like last time, in this case it's 2, and we call that A, which is the first term. Okay. So now, just like last time, we have some formulas to look at. Can I scroll down? In a moment, it seems. Turkey! Why are you late?
I missed it.
Yeah. Yeah, the critical time. Okay. Can I scroll down now? Yeah. Right, so let's just take a simple example, and I want the A and I want the OR. So for example, let's say something like 3, 6, 12, 24, 48. Just, I know it's very easy, just write down the A and the OR, just as our first example. But I know, of course, this one's easy. Okay. Right, what's the A here? 3, and the OR? 2. So that was easy. Now let's look at some formulas though. So, we start off with A, and if we're multiplying by OR each time, so this is the first term, the second term would be A OR, this is the second term, and if I multiply by OR again, A OR squared, this is the third term, and if I multiply by OR again, I get A OR cubed, this is the fourth term. So by looking at these, you can come up with the formula. This is our first of 2 formulas for this class. UN equals A OR, and what's the power? In this case, yes, n minus 1. Because you notice that the power is always one behind the term. So the fourth term is a cube, so the fifth term will be 4, and so on. So this is our first formula, like this. Okay, so let's have a look at a not too difficult example. Okay, so here's our next example. Find the nth term in 9, 27, 81, ... So we want to find a formula for the nth term. So I'll just give you I'll give you a minute to try it. It's very much like what we did last time, where you leave n in your answer. Okay, you have this one? Yeah. So the A here, what do we get? 9. And the OR? 3. So the UN is A or n minus 1. Now we can clean that up a little bit. So for example, if you wanted to, you can change this into 3n over 3(1), and we've seen this last week in the tutorial actually. This just means I can do 9 divided by 3, which is 3 times 3 power n, and that's fine, but in fact you can simplify it more. This is 3 power 1 times 3 power n. Does anyone know what this becomes? Yeah? Yeah, 1 plus n. Yeah, now we haven't done these rules yet, so that's okay if you didn't know that. This would be fine to leave the answer like this, okay? But I'm just telling you that you can also simplify the answer a bit more down to here. But this is okay to leave it like this. Okay. Let's move down to another example. How many terms are in, and we'll say 3, 6, 12, ... 3, 8, 4. So again, all of this should be reminding you of what we did last week with the AP. How did we find how many terms we had last week? No.
Formula.
Which formula?
UN
equal to? That's it. You make UN equal 384. Yeah. So why don't you see if you can find the n from that formula, and I'll do it in a minute. Okay. So it's just like last week. Make UN equal to the last term. Okay. See if you can do it, and then I'll do it in a moment. Okay, let's see what we get here. So, well, first let me write down the A and the OR. So A equals 3, OR equals 2. And we don't know what the n is. That's what we're looking for. So again, just like last time, it's exactly like last time. UN equals 384. 3, 2, n minus 1 equals 384. Now I can see that this divides by 3 as well. I can put a 3 in here, and I can put a 3 in here. So that's great because they cancel. I'm left with 2n minus 1 equals 1, 2, 8. Is that right? Yeah. Now you can use, if I go to the side for one moment, you can use what you learned a couple of weeks ago about the factorizing, so the prime factorizing. So that's 64 and 2, that's 32 and 2, that's 16 and 2, that's 8 and 2, and the 8 is 2, 2, 2. So we have 1, 2, 3, 4, 5, 6, 7. So 2 power 7 is 128. So we can say 2n minus 1 equals 2 power 7. So we can we should see what the n is here. So n has to be 8 then, because it's the only way for this to work. 2 power 8 minus 1 equals 2 power 7. So here we get oh dear. There are 8 terms in this sequence. 8 terms. So still very similar to what we've been doing last time. Now the next type of example is a little bit different, and then we have our second formula to do. I made the numbers in today's lesson work nicely. In the exam, they don't have to work this nicely, but there is some other way you can find the n here. I'm sure some people know it. Does anyone know it? Yeah. We haven't done it yet. We'll do it in the next chapter. There's something called logs, and these are useful for finding powers, like exactly in this problem. So that's something we'll look at in the next chapter then. But for today's lesson, all the numbers work out nicely. Okay. Next example now. I tell you, UN is geometric, of course, a geometric progression. And I also tell you that the third term is 4, and that the 8th term is 128. Okay, and I think I'll do this one with you. A little trickier. Now, you should remember last time when we had this type of problem, there was enough information in 2 terms. I've given you enough here to find both A and OR. There's enough information here. Using our formula, we know that U3, the third term, is A OR squared. That should equal 4. And here the 8th term, A or 7, and that should equal 1, 2, 8. Now there are a few ways you can solve this, but there's one very nice way. Does anyone know what's the best way to go next? Not subtract, I don't think. Divide. You could do substitution, but what I like to do here is we write them both together like this, and we can add, subtract, multiply, or divide. And we haven't done this yet, but we're going to divide the 2 equations. So divide. I know you said that. I didn't say you were a liar or something. You know? So dividing here, the a's cancel. Or 7 divided by or squared. Or 5. And what is 32, is it? Yeah. So, you have this on your calculator, the 5th root, which is 2, 4, 8, 2. Yeah. So the or equals 2. You all have this button on your calculator, 5th root. Yeah? Yeah.
I have to customize it.
Yeah, yeah. Now, how can I get the A? Well, that's like usual. You sub it back in here. So now we get A times 2 squared, which is 4, equals 4. So you can see clearly what A is. It has to be 1. So I found the A and I found the OR. So in some ways, this is actually easier than with the arithmetic. Well, okay, maybe it's not easier, but it's just as quick. Like with the arithmetic example, I think all we had to do was just minus, and then the A's cancelled, if I remember. So again, it's pretty quick, this type. Okay, so if you write that down, what I want to look at next then, well, no surprise, it's just like the arithmetic lesson. So what's the next formula to look at? The sum, yeah. Okay. Right. Can I scroll down? Yeah. Is that a yes?
Sure.
Oh.
Why don't you just zoom out? Wouldn't that be easier?
Zoom out from what?
I don't know.
Like this?
More.
No, I want a full page. Okay. We got the connection for my laptop to use this projector from Amazon, but they sent the wrong one. So they wanted us to send a picture and email it to them to show that they sent the wrong one.
What?
They're such jerks. Alright. Okay, can I scroll down? Yeah. Right, so next we have our sum. So we want to calculate Sn, which is the sum of the first n terms of the sequence. So we start off with A is the first term, of course, and the second term is AOR, and the third term is AOR squared. And if we jump to the end, what's the last term? N minus 1. And then the second last term? N minus 2. And then AOR N minus 3, etc. And what we're trying to get here is a formula, and I wonder if anybody remembers from high school what is the trick in proving this formula? Oh yeah, I had to write the second one down.
No, one is for something that's...
One is for something and the other's for something else. True, yes. Yeah. You can remember being shown this last year, is it? Anybody remember from high school? Nope. Long gone. That's towards the end of it, yeah. Okay, nobody remembers. So what we do next? Last chance, anybody? Good try, but not this time. This time, what we do is we multiply everything by OR. So we have OR Sn equals AOR plus AOR squared plus AOR cubed. Do you see what is happening? All the ORs get an extra 1 because we're multiplying by OR. Dot dot dot. So the last one won't be AOR N minus 1. What would it be? AOR N. And then the second last one? N minus 1. AOR N minus 2. Now, how to combine these? Not divide. Subtract them. Because you notice what happens here. We have an AOR minus AOR. So these cancel. We have an AOR squared minus AOR squared. So they cancel, and they keep cancelling diagonally like this. Until you're left with just this one at the end, and this one at the start. They don't have anything to cancel with because they're at the start and the end. So this becomes A minus A or n. So we can take out the 1 minus or, Sn, and we can take out the A 1 minus or n, and then just divide by 1 minus or, and we're left with Sn equals A 1 minus or n over 1 minus or. And all we ask is that or is not 1, of course. And this is our formula for the sum of a GP. I was just about to say that.
Do we have to learn this proof?
No.
We have to learn any proof.
In semester 2, you'll have to do, they'll ask you to prove a couple of things, but they're not really, it's not like there's a list of proofs. There's a couple of things in trigonometry that they'll ask you to prove. Trigonometry identities, but there's no list of proofs to learn. So there will be stuff to prove in semester 2. So, you don't have to know this proof, but it's good to see proofs anyways. Can I scroll down a bit?
So nothing in semester 1.
There's nothing in semester 1. Yes. Okay. Well, the only proof, does anyone remember the only proof type question we've done so far?
We did the one with the sum last week.
No, the proof question you had to do. No. Do you remember?
We did a trigonometry one. Proof.
It was one with the complete the square where you had to prove something was always positive or always negative. That's been the only real proof question so far. Okay, now some of you are thinking back to high school and you remember, hang on, let me just scroll to the left for a moment. You might remember that, in my maths book or maths class I had two formulas. I had this one, which is like this, and then I had this one, which is the other way around. Yeah, some people remember this, okay? Yeah, I don't know why maths books do this. They're exactly the same. If you really think about it, the only difference between this and this is you multiply the top and bottom by -1, and it flips them around. But there's no number value difference. So, in other words, my point is, whenever you thought you had to use this, if you did use this, you would get the same answer. And whenever you thought you had to use this, if instead you used that, you'd still get the same answer. In other words, this is completely redundant. It doesn't do anything. It's only one of them is what you need. I have no idea why some maths books give these two formulas as if they're two different things. It'd be like me saying, oh yeah, we have minus b plus or minus the square root of b squared minus 4ac all over 2a. Or the second formula is plus or minus square root b squared minus 4ac minus b all over 2a. Which of course is the same thing. You realise that all I've done is just put this one at the back and the other one at the front. Which is exactly the same thing here. I swap these around and swap these around. So I have no idea why some maths books give the two formulas and some just give one. I don't know.
They're supposed to make our life hard.
Well, it's true. It is supposed to make your life hard, but they don't need to be stupid at the same time as making it hard. So you only need this one formula, okay? The second formula doesn't do anything. It's the same. I don't know. Maybe if somebody had their maths book, maybe they can see if there's an explanation in the book. But usually the explanation is, if or is between, something like if it's or between 0 and 1, you use this formula. And then if or is bigger than 1 or something like that, you use the other formula. It doesn't matter. This works for all values of or, except for, of course, 1. Because we'll be dividing by 0, which is a problem. Okay. So we'll have a look at some examples now with this. Make sure you have this formula written down. And we'll have a look at an example. Okay. Can I scroll down? Yeah. Okay. Right. Let's say something like this. Calculate S9 is 1 plus 2 plus 4 plus dot 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 plus 256. A is 1, or is 2, and is 9. Okay. So we just use our formula. S9 is A 1 minus or power n, yeah, over 1 minus or. 2, 4, 8, 16, 32, 6, 4, 1, 22, 256, 5, 10, 1023, is it? Oh, I have a calculator today. No. 511. I was off by 2. 511. Okay, so what I want to show you is that this actually does work using the program here. Can I... Well, I'll go back to this, don't worry. Go away. There we go. Okay, what was the first term? 1, wasn't it?
Yes.
And then I'm multiplying by 2 until I get to 256, which is, I've gone too far. So if I add up all of these, I should get 511. And I do. Okay, so you can see that the sum formula works then. Okay, I'll give you an example to try. Oh, you need to write this down. Okay. Okay, so I want you to try this one. You can leave n in your answer, okay? So I want you to find the sum of this, okay? And you can leave n in the answer. Okay. Let's have a look at this one. What's the A? 2. And the OR is 3. So the sum of the first n terms, oh dear, is A 1 minus OR n over 1 minus OR. So that's going to be 2, 1 minus 3n over minus 2. So that would be minus 1 minus 3n, which will be 3n minus 1 is the final answer then. So you can test it out. For example, when I put n equals 2 and add the first 2 terms together, what should I get? 8. So let's try that out. 3 squared minus 1 is 8. So it does work. Okay. Right. Next now. Okay. Again, I'll let you try it first. I want you to calculate this. Try this one. Yeah, find the sum, but first you'll have to find the n.
One minus 2 and then plus 2.
Yeah, the sign goes 1 minus 2. The sign goes plus minus, plus minus.
Oh, okay. So that's A is 1 then.
Yeah.
So what are you talking about?
Minus
The sum.
without all something.
Hmm?
Sound like CSGO, Bomb had been planted.
Don't worry. If there was a bomb, I'll be the first one to leave. Right. Okay, did you find the n first for this?
Yeah.
Yeah? So the a is 1 and the or is minus 2, yeah. And the n is what we want first. So we have a or n minus 1, so this is un. That should equal 256. Okay, now 256, 2, 4, 8, 16, 32, 64, 128. Is this 7? 2 power 7? No? 2 power 8, is it? Thank you, 2 power 8. And this is minus 2 power n, minus 2 power n minus 1. Now, it is 2 power 8, that's true, but if I want to match this up, it's also the same as minus 2 power 8. And now this way you can actually make a comparison. You can see that the n must be 9 then. So if I use my sum formula Sn, so it's S9 equals A, 1 minus or n over 1 minus or. What's 2 power 9? 512, isn't it? So on the top will be minus 511, and on the bottom will be 3. No, that's not right, is it? Is that right? Can you check on your calculator? Let's see. Oh, sorry, no, it's 513, because it's 1 minus minus. So it was 1 minus minus 512 over 1 minus minus 2. So that's 513 over 3. Yeah, and this does divide by 3, doesn't it? 1, 7, 1. Okay, now there's a very easy way for me to check. Just one sec. If I just go back to this and just change this to a minus 2, and we're still going up to 256, and yes, I do get 171 here. Okay, question, yeah?
The part where you did minus 2 and minus 1 equals minus 2
Yeah.
and minus 8. How do you know for sure that minus 2 and minus 1 is the same thing as when you put minus in front of it?
Yeah, in other words, why am I, or how do I know to do this? Yeah. I suppose the way I'm thinking about it is that 256, you can write it either two ways, and both ways are valid. You can write it as 2 power 8, or in fact you can write it as minus 2 power 8, and the reason is the power is even, so it means that the sign doesn't matter anyways. And usually it is this one, but in this case we need to use this minus one, so we can make a nicer comparison between the left and the right.
So what if it's an odd number?
If it's an odd number, then you can't put the minus in because then you're changing the sign.
How do you get anything?
Well, let's say this was, for example, like a 7, wasn't it? Yeah, and this was a positive, like 256. So then this is a, I suppose, would this be okay? Because then if that's a 2 power 7, you need this to be a 7, but if that's a 7, yeah, then I don't think that would work. It probably means you made a mistake because you would have a negative on the left and a positive on the right. So I can't imagine it working.
It doesn't happen that.
No, it shouldn't happen. It shouldn't happen.
You can use the log rule also.
We can use the log rules to get the n here as well. Then we don't have to worry about this business, but we haven't done logs yet. Okay, so 171 is the answer. Okay.
What's the point of saying that negative? We can change it to -2.
You mean here?
Yeah.
I'm just showing you that you actually have a choice on how you want to write it. Choosing the -1 was more convenient this time. That's all. Okay.
-3.
Huh?
-2.
So the -1, not number 1. The minus, 1 being used like a pronoun, okay? Right, continue? Yep. Now, let's have a look at another example. So, let's say something like the 7th term is 2187 and the sum of the first 4 terms of our geometric sequence is 120. I'll give you a minute to try it. S4, yep. Yeah.
What are we saying?
Sorry, again the A and the OR. So I think everybody got this one. A or 6 equals 2187. And here, A, 1 minus or power 4 over 1 minus or equals 120. So I'll just give you a couple of more minutes to see if you can figure out how to solve that. Anybody have any luck yet? Oh, okay. Okay, I'm going to do it now because well, did anybody get it? No, I wasn't expecting anyone to get it. Although, well, secretly I hope maybe somebody got it, but no. Okay, so the first thing to do, your term on the right, you should actually simplify that a little bit before going ahead. And does anybody, this is something you, I think, should know because we actually did it. Does anyone know how I can simplify the term on the right here? This one. Yes? 4 minus, no, not this.
No.
No.
You can.
No.
Yeah, you can do.
No. No.
Not 7
No.
minus 1.
No.
You can do.
No.
You can do 1 minus alpha.
No.
1 plus
No. No. Long division. Remember, we did long division to simplify these. So, we have this, we want to simplify. To make it a little bit easier, I'm just going to write it like this, which is the same thing, because it looks a bit more like what we did previously. So, we divide r minus 1 into r4 minus 1. What do we have first? R cubed. So this will be r4 minus r cubed. And when I subtract, I'm left with r cubed minus 1. So the next one will be r squared, yeah, and then I have r cubed minus r squared, and I'm left with, that's a 1, isn't it? I'm left with r squared minus 1. So next will be, and then that's r squared minus r. So now I'm left with r minus 1. So the last one is 1. So we have 1 plus r squared plus r cubed. And we knew before we started that the remainder would be 0, because if I just go up to If I go up to this, if I said take this and divide it by this, 1 minus or 4 divided by 1 minus or, you can use the remainder theorem. What should I use for or in the remainder theorem if I'm dividing by this? 1. Yeah, so if I put 1 into this, what do I get? 0. So you actually knew before you started that you should get a 0, that it does divide. Okay, so now if I return back to the question, this is only a long division, which you all should be able to do without me writing it down here. So now I can simplify a little bit. A or 6 equals 2187, and then this is A 1 plus or squared plus or cubed, wasn't it? Equals 120. Okay. So I can rewrite this as A equals 120 over 1 plus or squared plus or cubed. And here I can write this as A equals 2187 over or 6. Yep, is that okay? And I can make them equal. So I have 2187 over or 6 equals 120 over 1 plus or squared plus or cubed. And I think I'll just bring the or squared up and the 120 down. So do I get anything nice when I do that? This will be 729 over 40 equals or squared over 1 plus or squared plus or cubed. Oh, is it? So sorry, thank you. Or 6. Or 6, thank you. Okay. Now. 729 over 40. That's the same as 2187 over 120 on the calculator. Okay, continue. So 729. If I want to factorize that, what you can check on your calculator, but that would be 3 power 6, and you can check it if you want, but it's 3 power 6. Okay. 40 is the same as 1 plus 3 plus 9 plus 27. Now you might say, why is he writing 40 in such a strange way? Well, if you look, you'll see on the next line the reason why I made such a choice for writing 40. 3 power 6 over 1 plus 3 squared plus, 1 plus 3 plus 3 squared plus 3 cubed equals or 6 over 1 plus or squared plus or cubed. By writing my 40 in such a strange way, I can match perfectly the left and the right. So just by looking at this, you can see what the or must be if the left and right are to be the same. Yeah, it has to be 3. Now you might say, well, what was my hint for doing it like this? And my hint was, when I look at the top, I got 729 here, and here I have or power 6. So on the calculator I could see 729 was 3 power 6, so it made me feel like I should try and make 40 as a sum of 3's of this form. And I was able to match that up.
If you weren't, would that be correct?
And then we can get the A back as well. No, it was, I made the numbers in this question so that you can match them up, but it doesn't have to be as nice as that.
Can you give us an example where it's not as nice?
No, that would not happen, that would be too cruel. Yeah. You can put the or back into whatever, like this one here, and you get, what did you get for A? 3. So this makes A equal to 3 then as well. Now this is a very, very difficult question. Very difficult question, okay? So difficult I forgot how to do it and I had to watch my video from last year on how I did it. So, past Stephen was able to do it. Present Stephen is too tired and sick to do it. So this one is tricky for sure. In fact, probably too tricky for the exam. But like I said, it's good to try some hard ones from time to time. It makes the exam a little bit easier. So there's one example left to do, and then that's the GP. So the last example. What's wrong? It's a double class. It's a double class. Chill out. Right. The last example.
Where did the 40 come from?
He asked me that.
Simplify it
That 2187 divided by 120 is 729 over 40. Have you got your calculator? Right, last one. I tell you that this term, and this term is in geometric progression. Find the x. So if you think back to the arithmetic example, the idea was that the second term minus the first term equals d, and the third term minus the second term is equal to d. So then we can make them equal. What about for geometric? What can we say? Yeah, the second one divided by the first one is or, and the third one divided by the second one is also or. So you can have minus 4x minus 4 over minus 2x plus 3. That should equal or. But or should also equal minus 8x minus 4 over minus 4x minus 4. So we get this equation.
Are you writing?
Yeah. And I'll actually stop there because the rest is now just an algebra problem. What should we do to finish it? Well, we'll need to bring this up to the right and then this one up to the left. What type of equation will I get on the left here? A quadratic, and on the right? A quadratic. And then you bring all the terms to one side and then just solve that quadratic. So I think all I really needed to do was just to get this started, but really you should be able to continue it from there. It's really just an algebra problem now. In particular, a quadratic. In fact, it won't be a quadratic, it'll be even easier than that. I can see that the x squareds are going to cancel on both sides, so you'll be left with a linear, which is even easier. Okay. Right, so I'll give you some questions to do for homework, and then what's our next topic after GP? Okay. Can I close this? Yeah?
Is it okay if we have a 10-minute break?
No.
You always say that life is hard and you don't easy enough.
Shh. I said not a 10-minute break, but you can take a 5-minute break.
7.
This is not a negotiation.